Hi everyone, welcome to week 3 stats lecture in which we're talking about Stata, intro to Stata, and inputting some data in Stata. So, a bit of a lecture outline. What we're doing today is going to be briefly recapping a couple of the concepts that we talked about last week in terms of different kinds of variables. And I'll be talking specifically about how do we think about variables in terms of how we store variables in a data set. So I introduced you to the concept of a data set last week. I'm sure it's something that probably wasn't new to you, but anyway, in the context of these courses, I introduced you to the concept last week. And what we need to think about when we're thinking about how we're storing data being information that we've collected from a research project, is how a statistical program, in this case Stata, thinks about that data. So we need to think about how the stats program works with data, how it thinks about data, and therefore what the best way is to store data so that we get the most out of our data in terms of any kinds of statistical analyses we might want to do. We'll also talk about variable types in Stata, so different types of variables that we can have. And then I'll spend a little bit of time actually in Stata itself just playing around with it, showing you a few different features, showing you how to make a new variable, how to change variables, all that kind of stuff. If you are psychology students, if you are enrolled in a psych degree and you're planning on continuing with your psych degree, then this course is just the first of many courses in which you'll be talking about stats and using a statistical program to do statistical analyses. So my advice to you is the more time you can spend now when it's new to you, in terms of familiarizing yourself with the program, playing around with it and just getting a hands-on experience of doing it yourself, the easier you're going to find those later courses. And even if you're an education student or a linguistics student or someone who isn't continuing with psychology, if you're going to be doing anything where research and data collection and data management is a relevant skill, again, the more time you can spend practicing yourself, thinking about it and playing around with it in this course, the better you'll be suited to doing those other things later on. So my advice is just to spend as much time as you can just getting a hands-on experience of doing it. Okay, readings and quiz. So you do have a textbook reading for this week in that there is a page there. There isn't actually any content in it because it's all a hands-on doing stuff yourself week, so there isn't statistical content as such to learn, but you still do have a quiz for this week. So the quiz is going to be a Stata-based quiz. You won't have to do anything in Stata yourself for the quiz, and that you're not expected to perform any kind of analyses, but the questions in the quiz will be Stata-based questions. Alrighty, so last week we spent a fair bit of time talking about different types of variables, different kinds of variables. And first I made a distinction between qualitative versus quantitative variables. Qualitative variables being categorical variables where you've got categories or types of things. Qualitative variables are descriptive type variables, whereas quantitative variables are your numeric variables. They're measuring something that's on some kind of numeric scale. So it could be a count of something, it could be a numeric measure of something. I also talked to you about 4 more specific types of variables, and those were nominal, ordinal, integer, and ratio variables. Nominal variables are your qualitative variables, your categorical variables. Integer and ratio variables are both quantitative, numeric variables, and ordinal variables are special because they can be either qualitative categorical or they can be quantitative numeric. So anytime you're looking at data, if it's a piece of data or a collection of data that's already been collected, or if you're about to collect some data yourself, it's a really important process to go through in terms of thinking about what kind of variable is all of the variables that you want to collect. If I'm asking people about their age, that's a numeric variable. That's a ratio variable. If I'm asking people about what degree they're studying, that's a nominal variable. That's a qualitative variable. So when you're engaged in the research process, then you need to think about what type of variable are all the variables that you want to measure. So remember, we've got distinction between these different kinds of variables, and this is going to become relevant when we think about how to store data in a stats program. Okay, I also want to remind you what a data set looks like. So this is a spreadsheet, this is an Excel spreadsheet, but it's essentially the same thing that we'll be talking about in terms of Stata. So a data set is essentially just a spreadsheet where the columns in the data set are the individual variables themselves. So here you can see we've got 4 variables. We have an ID variable, a gender variable, and we have 2 variables which are measures of PSYU1105 and 104 grades, or SNGs specifically. So we've got 4 variables, and we have 6 observations here. And an observation is just an individual, in this case person, who we've collected data from. So you can see we've got 6 people, ID 1 through to ID 6. They're all anonymous people, and each person is an observation in that we have data collected on numerous variables from each of these people. Okay, so this is our spreadsheet that's got all the data that we've collected in it. So in terms of thinking about if you were to set up a spreadsheet to begin with to enter data, it's an important step to think about in terms of wondering what kind of recording method you... Okay, so storing data. So in this spreadsheet, obviously our data are already in the spreadsheet. It's one that I prepared earlier, you could say. But when you're setting up the spreadsheet to begin with, you need to think about what format you think is most appropriate for the data to be stored in. So in terms of that, there are 2 kinds of ways that you can store data in a database or in a spreadsheet. And this is really important for your stats program, if you're using a stats program to analyze data, because how the data are stored in the spreadsheet will dictate what you can actually do with the data, whether you can analyze it the way that you want to analyze it or not. So there's 2 different ways of storing data in a database. There's more than 2, but there's 2 that are most important for our purposes. The firstly is in terms of a numeric type data, and the second one is a string type data. So numeric data, I know that I'm using the word numeric to mean a lot of different things throughout these lectures, and I apologize for that. But numeric type data is data that is stored in terms of numbers in the cell of the spreadsheet only. So if I go back to my Excel spreadsheet, there are some variables here where there's numbers entered into the cell. Those variables are numeric type variables. So a numeric type variable is one where the only pieces of information, the only characters that are entered into the cells of the spreadsheet are numbers. They're numbers only. The other kind of variable is called a string variable, and a string variable is very flexible in terms of what you can store in the cell. String variables, you can store anything in the cells. They can be letters, they can be numbers, they can be characters, they can be symbols, spaces, quotes, anything that you want. So numeric type variables are very specifically only numbers. String variables are anything. So again, going back to my Excel spreadsheet here, you can see that our gender variable is a string variable because there's text that's entered into the cells. I've got the words female, male, and other. Whereas ID, PSYU1105, and PSYU1104, they're numeric type variables because it's only numbers that are entered into the cells. And this might seem like a weird distinction to be making, but it's actually really, really important because if we want to perform any kinds of statistical analyses, which we will want to be doing, you will be doing whether you want to or not, what we need is numeric type data. Our statistical programs can only handle or can only deal with numeric type data in terms of doing the analyses that we want to do. So we need numeric type data to perform the statistical analyses that we want to perform. So for our purposes, what we're going to do almost solely is deal with numeric type data. But what that means is that what we need to do is to think about how to store other kinds of variables, variables that aren't numeric type variables, is how to enter it into the spreadsheet. So if we have qualitative data, so remember qualitative data, qualitative variables are categorical variables, things like gender, things like color, things like unit of study, anything that's a descriptor as opposed to something that's a numeric measure. What we need to do is to code each of those categories and assign each of those categories a number and enter the number into the spreadsheet instead of the word itself. So to give you an example, let's say we had gender, let's say we had 3 levels or 3 categories of gender, male, female, and other. What we would do would be to code each of those distinct categories as a number and enter the number into the spreadsheet in Stata instead of the actual word itself, instead of the text descriptor. So you can see here that we've assigned male a coding of 1, we've assigned female a coding of 2, and we've assigned other a coding of 3. The order of these numbers does not matter at all. It's completely arbitrary and it makes absolutely no difference to anything you do, the fact that male is 1, female is 2, and other is 3. It makes no difference. It's convention to have sequential numbers. Why that is for your purposes doesn't matter. When you go on to do higher order stats, we'll talk more about why that's important, but for the purposes of this course, you don't need to care about why sequential numbers are beneficial. It's just convention for your purposes. So sequential numbers in terms of consecutive numbers are good, but there's no need to have male as 1 compared to female as 2 compared to other as 3. It's completely arbitrary. The order doesn't matter at all. So take-home message from this is to use numeric type data only when you're storing data in a spreadsheet, when you're entering data into a spreadsheet. So all of your descriptor type variables, all of your variables that are qualitative variables as opposed to quantitative variables, they will be coded, and the numbers that represent each of the categories will be entered into the spreadsheet itself. The exception to this is if you need to store text data in your data set. This is pretty unlikely. For your purposes in terms of this course, this will never be an issue, so it's not relevant for this course, but in terms of real life, the exception to using numeric type data is if you really do need to be able to store text data in the same spreadsheet along with the other pieces of information. So let's say you asked people their name and you wanted to have a name variable in your data set, then that would be a string type variable rather than a numeric type variable. That's the only exception, and again, for your purposes in this course, we'll only ever be dealing with numeric type data just because it makes life simpler, and that's the kind of data we need to do the kinds of analyses that we want to do. So as I said before, the statistical programs can't actually analyze string type data, which is why it has to be numeric data. It has to be, all of our categorical variables need to be coded, or our numeric variables just entered in as the numbers themselves, which is what that says. And then what we can do is we can tell the stats program, in this case Stata, what that coding scheme is. So in the case of gender on the previous slide, we could tell Stata that male is represented by the number 1, that female is represented by the number 2, and that the other category is represented by the number 3. And I'll tell you how to do that in a second. The next couple of slides are some Stata-specific terminology. It's not actually important that you take this on board. I really just included it there in case anybody's particularly interested, and in the giant cohort that you are, I'm sure someone will be. So this table just contains a list on the left-hand side of Stata terminology of different types of variables. On the right-hand side, that distinction between numeric and string variables that I came to earlier. So in Stata, there's actually 5 different types of numeric type variables that you can store, that you can have in your spreadsheet. You can see that the 5 different names for them there, so byte, int, long, float, and double. When I show you the Stata interface, this is the type of variable that Stata will be referring to the variables as. It doesn't actually call things numeric versus string, but each of these 5 types of variables are all just different subtypes of numeric variables. String it refers to as str. If you're interested, again, you don't need to know this, but if you're interested, this is the difference between those 5 different types of variables. The only restriction is how the actual byte size that the variable itself takes up in terms of the storage of it, and what the minimum and maximum values can be in terms of that numeric variable. So this is not important in any way, it's just there in case anybody's particularly interested in. Okay, different types of Stata files. So Stata is a program, it's a computer program, and just like any computer program, files that are in its native file format have a file extension, and the different types of extension tell you what different kind of file it is. So if you're using Microsoft Word and you're using a Word document, that document has an extension .doc or .docx, saying that it's a Word document. If you're using Excel, the Excel file has an extension .xls or .xlsx. Stata has 3 different kinds of files that we'll be talking about, and they have different kinds of file extensions because they're different kinds of files. So the first one, and the most important one, is a dataset. This is a Stata dataset, just like an Excel spreadsheet, isn't it? Kind of an Excel dataset. And datasets have the file extension .dta. So if you see a file with the extension .dta, that's a Stata dataset file. And that's the native file format in terms of having data and storing data in Stata. We can also have a text file which has the file extension .do, and this text file is a compendium of written commands or written programs that you can use to tell Stata to do stuff. So Stata is a statistics program. As I mentioned to you before, in terms of achieving anything in Stata, in terms of getting it to do anything, you can do that one of two ways. You can write commands, you can have written text commands and then run those commands, or you can use the menu system to call up different kinds of commands. If you're using the written commands, you can combine a whole list of these commands in what's called, in this particular type of text file, which is called a do file, .do file. The third type of file is a graph file, and that has a file extension .gph. So that's a Stata native graph file. I'll show you how you can copy graphs from Stata and paste them into, say, Word or any other program that you want to. So you can definitely copy and paste Stata graphs into different programs. But if you were to save a graph in Stata, it would be saved as a .gph file. Okay, so let's talk about Stata variables again. So all of your variables in Stata have to have a name. That's kind of just common sense. Every variable has to be called something. And there are very strict rules on what those names can be, on what kind of text you can use for those particular names. In particular, you can have either uppercase or lowercase or mixed letters, but Stata is case sensitive. What that means is that if you have a variable which is written out in uppercase, if you want to call on that variable or do something with that variable, you have to match the case in terms of how the variable name is actually written. I've come back to this a couple of times because it's important and it's easy to forget that and to use uppercase when you mean lowercase and vice versa. But in terms of variable names, they can be uppercase or lowercase. It has to be either a letter or a number or an underscore. You can't have any other symbols and you can't have any spaces in your variable names. So no spaces, only letters, numbers, or underscores. The first character of the variable has to be a letter. It can also be an underscore, but there's good reason to not do that. So just take my advice and just stick with a letter. The first character can't be a number. So it has to be a letter or an underscore, but my advice is to stick it as a letter. You can only have 32 characters long for variable names. My advice is to get nowhere near 32 characters. So as you'll see when you get a little bit more experience with doing stuff in Stata, you make life easier for yourself if you have short, succinct, easy to remember variable names. Because if you're typing out the variables and you have these very long variable names, it just makes life a little bit more complicated for yourself. So you make things simpler if you have short and succinct, but also easily understood variable names. Because there are those restrictions on variable names, there's another piece of information that you can store with each of your variables, which is called a variable label. And variable labels are just longer or more informative descriptions of the variable itself. So let's say we had a variable which was a participant's identification number. So each participant we assigned an ID number. That was to make all of our participants anonymous. And the variable name for that variable might just be ID. And you could see an example of that back a few slides ago when I had that Excel spreadsheet. So if our variable name is ID, a variable label could be a longer description of that, which might be participant's ID or participant's identification number. So in variable labels, you can have spaces, you can have apostrophes, you can have any kind of character you want. There's no restriction on them. Variable names are restricted. The third piece of information that can be stored alongside a variable is something that's called value labels. And this is only relevant for our categorical qualitative variables. So I said before that when you have these categorical qualitative variables, what you need to do is to code them. So to assign each category, each type, a number, a numeric code, and to enter the number into Stata rather than the text itself. So male, female, other was coded 1, 2, and 3. Value labels is the piece of information that you give Stata that tells it that male equals 1, female equals 2, other equals 3. And it's very useful to store that information in your data set because it's super easy to forget that afterwards and to not be able to remember which category is 1, which category is 2. So value labels are only relevant for your qualitative categorical variables, and they're the way of telling Stata what your coding scheme is for each of those variables. Okay, this is your Stata interface. Remember that this is taken from a Mac. So if you're using iLab, which uses a PC desktop, or if you're using Stata yourself but it's on a PC, it'll look very slightly different to this just because the icons tend to look a little bit different. All of the functionality is exactly the same though. So the layout will be slightly different, but not too different in terms of this screen. Okay, so there's a few things highlighted here that I just want to go through to show you the different pieces of the Stata interface. The screen in the middle is where the results of anything you do will be displayed. That's kind of your main screen. It's called the results screen, conveniently enough, because if I ask for a table, if I ask for a graph, if I ask for a statistical test, that's where it's going to come up. The command section down the bottom, this is what you can use to type in written commands, those written programs into Stata. And I'll show you an example of doing that when I actually do the walkthrough of Stata myself. In terms of this screenshot here, I don't have any data open. So I don't actually have any data set active in Stata at the moment. If I did, I would have a list of variables in the variables section over the right-hand side here. And if I selected any particular variable, then I could get the properties of that variable, including the variable name, the variable label, the variable type, and the value label if relevant. So this is a screenshot of Stata with no data open, which is why there's nothing there. What you can see is that we have some icons at the top as well, and I'm going to be talking about them as we get to them, as they become relevant throughout what we're talking about. Okay, if we wanted to open a Stata data file, then this is the process that we go through to use it. We could either click on the open button, the little open icon, the yellow folder on the left-hand side there, or we could just go File Open using the File menu just like you would do in any other program. So File Open, the default type of file to open is a Stata data file. So File Open, and then it brings up this secondary window where you need to navigate on your computer, in your computer's kind of space where the actual file is stored. So just like if you're in Microsoft Word or PowerPoint or anything and you want to open a file. As I said before, you can see that Stata datasets, the file extension is .dta, and that's the little preview that we get. So I'd select the file and I'd select open. What then happens is you can see in my results section here, there's some code that's been written out in blue, and this is the written equivalent of what I've just done in the menu system. So if you'd like to learn the Stata, what's called Stata syntax, the Stata code, then this is a really great way of doing it, because anything you do in the menu system, Stata will print for you the command of what you just did. So you can see the use is our command name, and that's calling up a particular file. And you can see that this is the path on my computer for where this particular dataset lives, stataexample.dta. What you can see now, because we've got a file open, is that in the variables section, there's a list of variables. We can see the variable name and the variable label. And if I select any particular variable in the properties window down the bottom right-hand corner, you can see the properties or the information about that variable. So our variable name is ID. The variable label, which is kind of run off the side, is participant's ID number. You can see the type of variable is a float variable, which you know is a type of numeric variable. And we don't have any value labels because that's not relevant for this kind of variable. If I wanted to actually view the particular data set, if I wanted to view that spreadsheet of data, then I could do it one of two ways. You can see that there's two icons at the top here. I have a data editor and a data browser. They will both open up the spreadsheet, but if you want to change anything, if you want to edit anything, you need to be in data editor. If you just want to view the data without actually being able to do anything about it, then you want data browser. Once you're in either of them, you can flip to the other one as well. So in this case, I'm going to click on Data Editor, and this is what comes up. Then I get a secondary window here, and this is essentially my spreadsheet, but it's a slightly more fancy spreadsheet to say an Excel spreadsheet, because each of the variables has information that's stored in the data set. So you can see that in terms of the main view of this data set, I've got my 4 different variables. I've got my 6 observations. Just looks like just that Excel file that we had before. And you can see on the right hand side there's the list of variables, and then for any particular variable that's highlighted or that's selected, that's the properties of the variable underneath there. So the next thing I'm going to do now is to get out of the PowerPoint slides and actually go into Stata and show you a couple of things within Stata itself.